Hello people, welcome to Gurukula. I'm Jai. So today in this video we are going to see about the topic that is access control in data link layer. And to be very specific, there are several methods of access control that is happening in data link layer, and we will be focusing on one type of access control, and that is what we term it as random access methods. So this is the first part of the access control mechanism, and there are subsequent parts to be released in the subsequent videos. So now today, without any further delay, let's get into the topic. So whereas in our previous videos we have covered the concepts such as framing and then the flow control. If you have not yet watched the previous videos, I will leave the description in the I section, and as well as I will leave the link in the description section. So please do check out the previous videos. And today in this video we will be focusing on what is access control, and then what are all the various types of access control mechanisms, especially related to data link layer is concerned. So first of all, we will understand what access control is. So what we will do is we will pop up three different figures so as to make you to understand why access control mechanism is really important in network scenario. So in order to understand that, we will assume that these three figures can elaborately define you that why access control is required. So whereas in the first case is concerned, you can see that there are very less number of people, those who are simultaneously accessing the radio network over here. And whereas in the second case there are moderate number of people, and whereas in the third case there are many number of people accessing the radio network at the same time, whereas simultaneously. So if this is the case, then there will be quite a lot of burden that will be imposed on the radio station, which is not possible for a radio station to serve for all the people, those who are trying to access the radio station at the same time. So here this is the area where we are implementing the access control. So access control is a mechanism for regulating the multiple users, those who are trying to connect or to access the common resources over here. So with this understanding, let us take it forward to understand the need for access control. So when in network scenario, when multiple number of nodes or stations are connected using a common link, then we need a multiple access protocol to coordinate the access. So this problem can be seen, or this problem can be framed by assuming that the people talking in an assembly over here. So while framing an access control mechanism, we should ensure that all the people should have a right to speak. We should not deny any people from talking to other one. So second point is we should ensure that the two people do not speak at the same time, so as to avoid the collision between these two people. And also the third point which has to be considered is the discussion should not be monopolized, it has to be an diplomatic one. So by keeping all these points in mind, we will have to frame an access control for the network scenario as well. So there has been many protocols that has been devised to handle the access to share a link. So all of these protocols belong to a sublayer in data link layer, which is called as media access control sublayer. So with this, we can see what are all the various classifications that is available for access control mechanism. Well, there are quite a lots of classifications available in access control mechanism, and it can be broadly classified into three types. First one is random access protocol, and the second one is controlled access protocol, and the third one is channelization protocol. So here in our Gurukula channel, we will be discussing each and every classification of access control mechanism in subsequent videos. So as far as today's video is concerned, we will be discussing a lot on the first mechanism under random access protocol, which is what we call it as ALOHA random access technique. So we will see what ALOHA is and what are all its types and what is the difference between its types. So talking about the first one, random access protocol, why does it got its name, that is random access protocol? It is because of two reasons. The first one is it is not scheduled time for any stations to transmit, which means that whenever a station wants to transmit, it is going to transmit. That is the very first thing which makes it random access. And the second reason is there is no rules specifies which station should transmit next. So there is no specific rule that once a particular station has completed its data transmission, who has to start the data transmission next. So these two reasons makes it completely random access protocol. And then in random access protocol, each and every station must follow a procedure that answers the following question. So these were all the few questions which a station should actually answer before transmitting the data. So when a station can access a medium, that should be a question. When a medium can be accessed by a station, and then what if the station do if the medium is busy, and then what can determine the success or failure rate of the transmission, and then what can a station do if there is an access conflict. So all these questions has to be addressed very carefully before jumping into the random access protocol or any random access mechanism is concerned. So first one, when we deal with the ALOHA, first let us set up an environment. As you could see in the figure over here, you can see that there are 4 stations which is accessing a common medium. So here this is what we call it as a common medium, and you can clearly see that this common medium is being accessed by 4 stations: station 1, station 2, station 3 and then station 4. Now let us see how these stations will communicate the data generated by themselves by using this common medium. So as far as ALOHA is concerned, it was developed in the year 1970 and it was actually designed for wireless LAN, but it can be used for any shared medium as well. So there are 2 types of ALOHA that we have. The first one is pure ALOHA and the second one is slotted ALOHA. So first we will talk about the pure ALOHA technique. So in pure ALOHA technique, there you can see that we have 4 stations as depicted in our environment. We have station 1, station 2, station 3 and station 4. So all these 4 stations is sharing a common link. So this axis represents the time, and just for the sake of understanding, it has been given the different timeline, but actually in practical scenarios this is going to be the same timeline. So when you observe that each and every station is transmitting 2 frames in the medium. So as you can see, this is frame number 1.1 we can take, which is actually represents that the station 1's first frame, and we can take this as 1.2, station 1's second frame. So similarly, the frame number for this will be 2.1 and this will be 2.2, and so here this will be 3.1 and this will be 3.2, and here it is station number 4 frame number 1 and station number 4 frame number 2. Now when you clearly observe this particular standard, you can clearly see that as consider this particular environment. So what is happening? Only station 1 is transmitting the frame. And also it is important to note that when station 1 is transmitting, there is no other station started its transmission over here, so that there will not be any collision for frame number 1.1. And you can observe the second scenario over here. When at this particular point in time, you can see that station 1 has started its transmission at this point, and then station 2 has started its transmission at this point, station 3 has started over here. When station 3 is actually starting the transmission, there is no other stations which is actually starting the transmission. See, I will repeat, when station 3 is actually starting the transmission, when station 3 places a frame on the medium, there is no other frames that has been placed by any other stations that is sharing the common medium. But when it started transmitting the frame, you can see that station 2 also started transmitting, and after a while station 1 has also started transmitting and station 4 has also started transmitting at the same time. So this shaded area is what we call it as the collision duration. So any frames that has been generated during this particular period will be collided each other. So this is what the drawback of the pure ALOHA technique. And whereas when you see over here, in this particular scenario, station 2 has started its transmission over here, and when station 2 is transmitting, there is no other stations that is been transmitting over here. But after a particular period of time, when station 2 is keep on transmitting the frame, you can see that the station 4 has also placed its frame in the medium over here at this particular point in time. So this entire duration will be collided, which means this part of the frame that is generated by station 2 and this part of the frame that is generated by station 4 will be getting collided. And no matter what, even if one bit of the frame is collided or is erroneous, the receiver is going to discard the complete frame over here. So that is what we will have in pure ALOHA technique. So now we will see how slotted ALOHA is working on the other side. So in order to overcome this particular problem, we have an slotted ALOHA on the other side, whereas in slotted ALOHA, a station can start its transmission only during a particular time slot. And even here we have the same setup: station 1, station 2, station 3 and station 4, but this time the time, you can observe that the time slot is divided into different slots. So we have 6 slots in total. And you can also observe that whenever a station wants to transmit, it cannot transmit at any point in time. It has to wait until the slot is getting started. So where you can see that station 1, this is the beginning of the frame and this is the ending of the frame. Similarly, for the second frame, this is the beginning and this is the ending. So you can clearly see that all the frames that has been transmitted by all the stations is beginning at the start of one particular slot. You cannot see that any frame is transmitted like this, as like in pure ALOHA. This is not allowed in slotted ALOHA mechanism. So as you can see over here, this will greatly reduce the collision that is happening in all the 4 stations that is sharing the common medium over here. So similarly, station 3, it starts here and then it ends here. This is the beginning of the frame, this is the ending of the frame. Similarly for the next frame as well. So it just means that every station should start its transmission only at the beginning of the time slot. If this particular station misses a particular time slot, then it has to leave the entire slot free. There is no permission for this particular station to start its transmission at the middle of the time slot. So that is not allowed for the station 1 as far as slotted ALOHA is concerned. So here when you can see that station 1 and then the station 4 is placing their frames at the same time. So these 2 frames will be collided each other and then it will be lost. So this will be the mechanism for slotted ALOHA is concerned. And you can clearly see that the slotted ALOHA is much more better and it is having much more less collision duration than compared to the pure ALOHA technique. So that is what it is. We call it as pure ALOHA and then the slotted ALOHA technique. So whereas in the second sense, we will have the second technique, that is what we call it as carrier sense multiple access. So whereas in carrier sense multiple access, we are going to use an principle, we call that as sense before transmit, or in general words we can assume that as we will have to listen before talk, which means that whenever a station wants, say for an example, I have a station over here which is connected to a commonly shared medium like this, and this particular station wants to communicate the data to this particular medium. Let's say when A wants to communicate its message to B, then it should first sense whether this channel is being used by any other channel or not. So only after verifying that the channel is free, then A is allowed to transmit its messages from A to B. So this is what the entire principle behind carrier sense multiple access, which means that multiple nodes can access a commonly shared medium, and before sending its data, it should sense the carrier for the idleness. So that is what the meaning for carrier sense multiple access, and in short it is represented as CSMA. Whereas there are 3 behaviors of carrier sense multiple access. The first one is one persistent, and second one is non-persistent, and the final one is p-persistent. And let us see one by one. Whereas in the first persistent, if at all a station wants to transmit, then it will sense whether the channel is busy or not. As you could see, it is continuously sensing the channel. and then you can see that the channel is busy for this particular period of time, and this block area is what we assume that the channel is busy, which means that this channel is being utilized or it is being used by some other stations. So a station who wants to communicate or to send any message should continuously sense the channel until the channel becomes free. You can see that the channel is becoming free at this particular point, and then as per as one persistent behavior, the sending node can immediately put its frame on the channel and it can transmit the messages. So this is what we call it as one persistent method. So here the drawback of this particular behavior is we will have to continuously sense the channel until when the channel is becoming free. So that we go for the another behavior, we call that as non-persistent, and whereas in non-persistent you can see that first of all a sending station will sense a particular channel, and then this channel is assumed, the channel is found to be busy at this particular point in time. So what is it happening? It is going to wait for a particular period of time, and then it will again sense the channel. So it again senses the channel at this particular point in time, and the channel is found to be busy again. So what will happen? Again it will wait for a period of time, and then it will sense the channel again, and then the channel is found to be free so that it can able to transmit the messages. So the waiting period is actually a random period. You can see that this is waiting period 1 and this is waiting period 2, and T1 and T2 is not equal. You can see that there is the sending stations will actually wait for a random amount of time, and then it will sense the channel again to check the idleness of the channel. And as you can see, even though the channel has become idle at this particular point in time, actually the sending station is transmitting at this particular point in time only. Fine. So for this particular area, for this duration of the time, the channel is not being used even though if the channel is being idle. So that is what we call it as the non-persistent method. And whereas when we come for the third one, we call it as p-persistent method, and it should be noted that p-persistent method is always used for slotted channels. You should have a slot, which means that each and every station that is accessing the channel will be given a slot to transmit. Only in this particular area a p-persistent behavior can be implemented. So what will happen over here? See, the sending station will continuously check the channel, and then once the channel is free, the station cannot immediately transmit as we have seen in the one persistent, because the channel is free, but now it should perform the second check. What is the second check? Remember that I said it is a slotted channel, so that particular station should check whether the free time belongs to its particular slot, whether it is the station 1's slot or not. Because even though a station has a frames to transmit and then the channel is free, but still the station cannot able to transmit. It should wait until the slot of that particular station comes. So that is what we call it as p-persistent method. So what it will do is it will wait for a random period of time, and then it will send with a probability of p. So here the station may send or it may not send. So there comes a probability. So what is the probability here? It will choose a probability of p, and then it will send the messages over here. And then if it is, say for an example, the channel is also found to be idle, the frame also has to be sent by that particular station, and the slot also belongs to the sending station, then the sending station can send its particular frame. So this is what we call it as p-persistent. So now let us just march a little bit, and then we will try to understand each and every behavior in a flow diagram format. So whereas in one persistent method, this is another approach to understand one persistent method. The explanation remains the same, but only the pictorial representation is a little bit formal here. So see what happens over here. As far as one persistent, the channel, first of all, the sending station has to check whether the channel is busy. If the channel is busy, it will keep on sensing the channel until the channel is free, and once the channel is free, then the station can transmit the messages. So that is what one persistent method is. And whereas for non-persistent method, you can see that the sending station is actually checking for the idleness of the channel. If the channel is found idle, then the station is allowed to send the data. In case if the channel is found to be busy, then it will has to wait for a random amount of time, and then it should repeat the entire process again. So that is what will happen in non-persistent method. So what will happen in p-persistent method? Remember that p-persistent method is applicable only for the slotted channel communication only. What is slotted channel communication? Each and every station that is connected in that particular channel will get a slot to transmit its message. It is as similar to time division multiple access. So it will first check whether the channel is busy, and then if the channel is busy, then it will keep on sensing the channel until it becomes free, and once the channel is free, it will actually generate a random number r that lies between 0 to 1. So here for the first case, let us assume that r is equals to 0.4, let us assume for the case 1, and then what will happen is it will just check whether it is greater than or lesser than the p value. So what is p value? The p is calculated with a function of 1 minus r. So in our first case, it is 1 minus 0.4, so that the value of p will be 0.6, so that the probability value is now greater than the r value, so that what it can do is the station can actually send, which means that the station has a frame, and also the channel is the slot also belongs to the sending station, so that the probability of sending the frame is much more higher. And in case what happened, let us take the second scenario. Now this case r is equals to 0.6. Now what will happen? P is equals to 1 minus r. So p will take the value of 1 minus 0.6, and now p is 0.4. So what will happen? The p value is lesser than this, so that it should has to wait for a slot, which represents that this particular free slot is not its own slot to transmit. It is some other station's slot. So that as per a slotted mechanism, one station cannot transmit in other stations' slots, so that it will have to wait for a slot of period, and then it will again initiate the same procedure again. So this is what we call it as p-persistent method of access mechanism. So in this video, we might have seen the two techniques. The first of all, we started discussing what is access control, and the example which we tried to understood what access control is, which is similar to people accessing the cell tower. When there are multiple people trying to access the cell tower at the same time, then definitely there might be few people, those who might be left unserved. So we have several mechanisms to address, and out of which the channel should check it's randomly, and when it is idle we can transmit the message, and when it is busy we have to check it again. So that is what the principle behind random access method will work, and out of which we have 4 different mechanisms, and out of 4 different mechanisms we have discussed ALOHA technique and then CSMA technique. And whereas in the subsequent videos in communication network, we will be discussing about what is CSMA CD and then what is CSMA CA is concerned. So with this, I am stopping my video, and then I am going to see you in the next video. Until then, it's bye from Jai and happy learning.